Hello friends and welcome to Constant Learners. In this video we are discussing some important concepts like Hadoop, Pig and Hive. And actually this is not a planned video, this is a request from a viewer who has her exam tomorrow. So this is sort of a revision video which is going to be very quick. Detailed versions of all of these videos will come in the future, but for now let's get started. So we have already discussed in the previous videos what big data is. Okay, so big data, don't mind my handwriting please. Big data is huge volumes of data. That means it is in large quantities. It has multiple formats. Okay, so it can be in the form of text, numbers, statistics, videos, audios, etc. Okay, and this data can be both structured and unstructured. Okay, so it can be both kinds of data. Plus this data is coming in very high speed. So speed is very high. That means we will have to store, manage, process and analyze this data also faster. Okay, now conventional systems were not able to handle all of these all of these things with the big data. That means they could not handle the huge quantities of the data, they could not handle the data available in multiple formats, and they could not match the speed of the inflow of the data. They could not process it that fast. So what happened? What came into existence? Hadoop architecture. Okay, then Hadoop architecture was created. Now, what is Hadoop architecture? Hadoop is actually an open source framework. Okay, so if you get an answer for this, you can write it is an open source framework. Framework means what? Framework means it's a template. Okay, so it's an open source template for software development. Okay, so this Hadoop architecture is an open source framework and it is developed it is written in Java. Okay, Hadoop is written in Java, and what can it do? It can store, manage, process and analyze big data. Okay, and this is what we want. Our whole the whole motive, the whole purpose of all of this is to analyze the big data so that we can get the important information, the information that can be used for business purposes. Okay, so Hadoop is useful for all of this, and Hadoop is so efficient in analyzing big data that in today's times it is used by most of the big companies like Google, Yahoo, Twitter, Facebook, LinkedIn, etc. Okay, now Hadoop consists of four main components. What are the four components? First component is the MapReduce. Okay, now as the name suggests, MapReduce is made up of two words. First is map and the second one is reduce. So what does the MapReduce do? MapReduce is first, it is a software framework. Okay, now this software framework helps the Java programs to process the data parallelly. Okay, so it processes the data parallelly. This is an important point. Okay, MapReduce does parallel processing or parallel computation on the data. Now, since it is performing parallel computing using multiple machines, okay, so multiple machines are being used and multiple machines are performing parallel computing on Hadoop data clusters. Okay, I've already told you what clusters are. No. So open source framework, this works on Hadoop clusters. Okay, clusters means what? Clusters are nothing but similar set of data. Okay, that means suppose I am talking about heart diseases. Okay, so all the data about heart diseases should come and be stored in one single place. That is known as a cluster, a data cluster. Okay, so MapReduce, it performs parallel computing using multiple machines on data clusters. Okay, and thus because of this, the speed of processing increases. Okay, so processing speed increases. Now this map and reduce performs two functions. One is the map function and the other one is the reduce function. Let's see both of these in detail. So I have taken out this image from the internet. This is by the guru99.com, and it's a very good image to understand MapReduce. Now see, the big data is given as an input. Okay, here the big data is being given as an input, and here in these two steps the map function is being performed, and here in these two steps the reduce function is being performed. Okay, in the map function what is happening? The data is being split. Okay, and then the data is being mapped. Splitting the data means what? The big data is being split into smaller data sets. Okay, the data is being split into smaller data sets. Okay, and then these data sets are being mapped. Mapping means what? Mapping means between elements of two different data models, some kind of relationship or some kind of mapping is being created. Okay, that means some kind of matching or some kind of relationship is being built between the data from two different data models. Okay, and that is known as mapping. That means similar field or similar kind of data is being mapped together, or some kind of relationship is being created between the similar kind of data. Now the output of the map function, yahan pe what output do we get? We either get a key value pair, that means a key and a value pair, or we get the output as tuples. Okay, and now this key value pair or tuples, it can be anything. It can be either key value pair or it can be tuple or multiple tuples, and this is given as an input to the reduce function. Now what happens in the reducing function? This data is shuffled. Okay, the data is being shuffled and then the data is being reduced. That means a lot of different functions are being performed, like sorting function or hashing function. Okay, and then this reduced output is either stored in the HDFS or it is given as an output to the user. Means whatever the user is demanding, whether the user is demanding to store it in the HDFS or the user wants to view it as an output on the screen. So then this reduce function gives the final output to us. Okay, I hope that mapping and reducing was clear. Now the second component is HDFS. Okay, second component of Hadoop architecture is HDFS, that is Hadoop Distributed File System. Okay, now what is Hadoop Distributed File System and what is the use of this? Now this is the most important component of Hadoop architecture. Okay, why is the most important? Because it manages the storage of data. Okay, so where the data has to be stored, how the data has to be stored, and how many times the data is replicated, all of this is managed by HDFS. Now HDFS also stores the data in large chunks, okay, rather than storing it into smaller data set, and that is why, how does it help? It can store a lot of data. Okay, it gives space to a lot of storage space. Okay, so more storage space becomes available because the data is stored in large chunks. Okay, it gives more storage space. Now HDFS consists of two nodes. Okay, one is the name node and the other one is the data node. See, as the name suggests, you can understand this is the name and this is the data. Okay, name node is the master and the data node is the slave. Now name node, what does it do? It stores the metadata, that means data about the actual data. Metadata means the data about the actual data. Like for example, whenever we store something on our, some file on our mobile phone or laptop, we have the location of that file, right? We have the name of that file, then date of when that file was created, then there is the size of the file, how many GBs or how many MBs is the size of the file. Okay, so this name node also stores the metadata, and that is why there is only one name node in an architecture. Okay, only one name node is required. Okay, but here this data node, this stores the actual data. Okay, so it stores the actual data, and thus that is why only one data node is not going to work. Okay, we will need multiple data nodes. Okay, we will need multiple data nodes, and that is why one architecture has multiple data nodes that store multiple sets of data. Okay, or you can say multiple blocks of data. Okay, now this name node, why is it called a master? Because it guides the data node. Okay, it guides the data node. What guidance does it give? What kind of operation is being performed on the data, whether the data has to be changed, whether the data has to be replaced, replicated, created, deleted. All of this guidance or all of this information is given by the name node to the data node, and that is why name node is known as the master and data node is known as the slave. Okay, so data node stores the actual data. There are multiple data nodes in one architecture system. Okay, and these multiple data nodes can store multiple sets of data, and thus what happens, the storage capacity of the architecture also increases. Okay, thus Hadoop cluster can store huge amounts of data because of the multiple data nodes available in the HDFS. So that was all about HDFS. I hope that was clear. Next point that we have to discuss is the third component, that is yarn. What is yarn? Yarn is yet another resource negotiator. Okay, it is an abbreviation actually. Yet another resource negotiator. Okay, notes you can get on the internet, so I'm not writing everything in detail here. But what is the job of yet another resource negotiator? Now this works on MapReduce. Okay, this is a framework. Okay, yarn is nothing but a framework that works on MapReduce. Okay, now I also have to tell you one thing, that whatever output is given by the MapReduce, it is stored in the HDFS. Okay, I have already told you this, just a reminder that the output of the MapReduce function is stored in the HDFS. Now yarn is a framework that works on the MapReduce. Okay, and there are two operations that need to be performed by the yarn system. The first one is the job scheduling, and the second one is the resource management. Okay, resource management. Now job scheduling means what? Job scheduling means it divides a huge job into smaller jobs. Okay, so job scheduling reduces a huge job or a huge task into smaller jobs, and it also helps in prioritizing. Okay, that means it decides which job needs to be performed first and which job can be performed afterwards, because sometimes the output of one processing can be used as an input of another process. Okay, so it is important to prioritize which function has to be performed first, or which operation has to be performed first and which operation can be performed afterwards. So these two are the jobs of job scheduling. And resource management means what? Now we know that Hadoop clusters, the Hadoop architecture works on Hadoop clusters. Okay, so this we have already discussed, that all the operations that are being performed by the Hadoop architecture are performed on actually Hadoop clusters, because the data is stored in the form of clusters. So whatever resource is required to process these data on the Hadoop clusters is provided by the resource management. Okay, so resource management provides the resources. It provides resources that are required to run the Hadoop cluster or to manage, process or analyze the data in the Hadoop clusters. I hope that this concept of yarn was also clear. Okay, now finally the fourth component is the common utilities or Hadoop common utilities. Now common utilities consist of nothing but simple Java libraries. Okay, Java libraries, or you can say Java files. Okay, and these Java libraries or Java files are required to manage or process the data in the Hadoop clusters. Okay, so whatever libraries, whatever Java libraries or Java files are required by MapReduce functions or HDFS or yarn, they are provided by who? By common utilities. Okay, so whatever Java libraries or files are required by MapReduce, HDFS and yarn are provided by the common utilities. Okay, I hope that this concept was clear. That was all about the Hadoop architecture. Now the next thing that we're going to discuss is the pig. Now in the pig, what happened actually, previously MapReduce was used, okay, to get the required output to process the data, but MapReduce used Java language. Okay, now we know that in MapReduce multiple operations are performed, like splitting of the data, mapping of the data, shuffling, then various operations like join, sorting, all of this are also performed. Okay, now in MapReduce, when the data was small, everything was very smooth. Okay, but when the data started increasing, the speed of the incoming data started increasing, it got extremely complicated to use MapReduce. Okay, then it wasn't feasible to use MapReduce, and then the pig was created. Okay, pig came into the existence. Okay, now what happened that in MapReduce, since the functions started increasing, the coding in Java also started getting complicated. So pig is something wherein we don't have to write such huge numbers of or so many lines of code. Okay, and that is why pig is far easier to use than the Java or the MapReduce function. So pig is actually a high level scripting platform. Okay, scripting platform means what? That means it uses a scripting language. Okay, it's a high level scripting platform that uses scripting language. Scripting language means what? That means the language is interpreted. It is not compiled. It is interpreted. That means it is developed for the runtime. Okay, that means the machine code or the code that the script that the user writes is converted to machine code. Okay, and this is not to be known by the user. Okay, all of this happens inside the machine. It is not told to the user, and thus we can say that in the Apache pig there is a high level of abstraction. Abstraction means what? That means whatever operations are being performed, so those operations are hidden from the user. How are those operations being performed is also hidden from the user. Okay, so the user only writes some lines of the script. Okay, some lines of the script, and this is converted into the machine code in the environment of high level of abstraction. That means it is not told to the user, it is hidden from the user. Okay, and then it is analyzed and the data is processed and the output is given to the user. Okay, now Apache pig, this also runs on Hadoop clusters. Okay, we've already learnt about Hadoop clusters. We're not going to get into the details of that. Okay, so this also runs on the Hadoop clusters. Okay, now what else can be? Also, Apache Pig is also used to store, manage and analyze big data. Manage and analyze big data. Okay, this is also a scripting platform used to store, manage and analyze the big data. Okay, now in Hadoop clusters also we have two components. One is the language that is sorry, in Apache Pig also there are two components. One is the language. The name of the language is Pig Latin language. Okay, and the second one is the engine or the runtime engine called the Pig engine that provides the runtime environment. Okay, now what happens, this Pig Latin language has replaced Java. Okay, in place of Java, the user only has to write the code in the Pig Latin language. Now in MapReduce, using Java, we had to the user had to write hundreds of lines of code. Okay, but here in Pig Latin language, only a few lines of script has to be written. Okay, we don't call it code, we call it few lines of script has to be written, and then this script is converted into the machine code under high level of abstraction. Okay, and the data is processed and the output is given to us. Okay, so now we know that the scripts are written in the Pig Latin language. Now whatever operations are being performed, they are performed by the Pig engine. Okay, so we can easily use Pig Latin language to maybe modify the data or create the data or completely delete the data or manipulate the data. So whatever operations are being performed, we can query using the Pig Latin language in the Apache Pig. Now whatever operations are being performed is performed by the Pig engine. Okay, so when we write the lines of scripts, what happens, this Pig engine converts this code into the map and reduce functions. Okay, so this Pig engine converts the scripts to machine code. Okay, that can be understood by the machine, and then it performs the it performs all the operations like passing of the data, checking of the data, okay, and optimizing of the data. Passing, checking means what? It checks for the syntax, it checks for spelling mistakes, and it also optimizes the data. That means it tries to see which is the most optimal or the best way of processing this data. Okay, and the Pig engine does that, and finally it processes the data and gives the output. Okay, so that is what is done in the Pig engine. This is all about Apache Pig. There's nothing more to it. Okay, the basic concept of Apache Pig is all of this. Also, there are 4 data models in Apache Pig. Data models in Apache Pig. Okay, first is the atom. That means atomic value can be used. Atomic data type can be used, like string, integer, long, double. Okay, then second one is the tuples. That means tuples can be used, or the if you know what is a tuple, the rows are actually in the relational data model, tuples are used to store the data. Okay, then third one is the bag. Bag is what? Bag is a collection of tuples. Okay, collection of tuples is known as a bag. And map is what? Map is a set, fourth one is the map, which is a set of key value pairs. Okay, now next up is the Hive architecture. Okay, now we know that data has been increasing day by day. Okay, initially the data was mostly structured. Okay, and this structured data was stored in the relational database management database management system. Okay, and the language used to query relational DBMS. Okay, the language used to query relational database management system was SQL. Okay, now since the data is increasing day by day and the data is available in multiple formats, okay, we need new and better ways to analyze this data. Okay, and it also has to be fast. So the Hadoop came into existence. Now Hadoop can analyze, manage both structured as well as unstructured data. Okay, and that too very fast using the functions like MapReduce, HDFS and yarn. Okay, using all of these components it can process and analyze the data, both structured and unstructured. Who can analyze? Hadoop architecture can. Okay, Hadoop architecture can do this. So obviously it was important for the businesses to move from RDBMS to Hadoop architecture, but it was difficult to transform everything or to move everything from a proper structured format into this Hadoop architecture. Okay, so what happened is, also the language that they used for querying was SQL. Okay, and here in Hadoop, HDFS was handling the huge data sets. It was storing the data sets. It was retrieving the data from the data set. So it was difficult to move the existing data structure to the Hadoop. Okay, now what happened is that Hive came into existence. Because of this, Hive was created. Now what is the speciality of Hive? Now Hive can store the data in the form of relational format only, that means in the form of tables. Okay, so Hive can store the data in the form of tables, and Hive also has an SQL dialect as a language to query. Okay, so the language used for Hive is known as HQL, that is Hive query language, and this is a dialect of SQL. Dialect of SQL means what? The commands, the words that are used in HQL are similar to SQL. Okay, so it is not difficult to learn this Hive query language and be able to query Hive. Okay, so this is the basic thing about how Hive came into existence and what is actually the process of Hive. Okay, that was all about Hive. Another thing is that Hive also works on Hadoop clusters. Okay, this is important. Hive works on Hadoop clusters. Okay, so Hadoop clusters are used for querying and analyzing the large data sets that are stored in the HDFS. So whatever large data set is stored in the HDFS, Hadoop clusters are used to query that data and give the output using the HQL language, that is Hive query language. Now Hive has some important features of Hive are, first is this one, that it is the language is an SQL dialect, so it is easy to understand that language and query the system. Okay, then there is flexibility also, because initially the data was only in the structured format, was stored in the structured format, but today the data is available in all multiple formats, and thus there is flexibility in the schema. Querying the data is very easy. Okay, then optimization is far better here. Okay, and data analysis is also easy. Okay, now Hive architecture has 5 components. The first one is the meta store, which stores the metadata. Metadata means, now as I told you that Hive stores the data in the tabular format. Okay, so it needs to store the metadata about the this tabular format. Okay, let me write here 5 components of Hive. First one is the meta store. So meta store stores the metadata about these tables, like the location of the table, when was the table created, the size of the table, etc. Okay, and it also keeps the track of different data sets that are distributed over the cluster. Okay, it keeps the track of the data, and it is very important. Okay, because we must know how much space is available, what all data has been stored, when was the data stored. Okay, and it also constantly keeps taking the backup. Okay, regularly it takes a backup so that the data isn't lost because of any error or faults. Okay, the second component is the driver. Driver. Okay, now driver is actually a controller. Okay, it helps in executing the statements. Okay, and it stores the metadata that is generated during the HQL queries. Okay, so it helps in execution of these HQL queries, and it also helps to store the metadata in the meta store. Third one is the compiler. Now what does the compiler do? It helps to compile the HQL queries. Okay, that means it converts the query to the execution plan. That means how the query is going to be executed, what will be the steps taken. Okay, or how the data will be recovered from the tables. That is done by the compiler. Okay, it decides the execution plan and takes the required steps needed. Okay, then the fourth one is the optimizer. Now as the name says, optimizer does what? It helps in the optimization of the execution plan. That means whatever execution plan is chosen by the compiler, matlab whenever we query using HQL, the user queries using the HQL language, what happens is the compiler decides how the plan will be executed. That means how the query will be executed and what will be the steps and how the data will be the output will be given. Okay, so optimizer chooses the best possible solution. So compiler, it gives multiple solutions. That means suppose this is a method of getting the output, this is another method of getting the output, this is another method of getting the output. Now optimizer chooses which is the best method, whether this is the best method that is going to take lesser time, or this is the best method that is going to take less time and less effort, or this is the best method. So optimizer chooses the best execution plan. Okay, and finally the fifth component is the executor. What does the executor do? It executes the task. Okay, after the compilation has been done, the best plan has been chosen, then the executor just executes the plan and it gives us the output. Okay, so all of the 5 components, I hope they are understood. Metastore stores the metadata, location, date, size, etc. Driver, it drives the HQL. That means whatever queries are given, it starts the execution of those queries and stores the metadata in the metastore. Compiler, when the a query is given, the compiler tries to find all the possible solutions of the query to give the output. Now optimizer chooses the best possible solution, and finally executor executes the plan and gives the output. I hope all of these, that is Hadoop, Hive, Pig, all of this was clear. If you have any questions, you can write it down in the comment section below. And if you like this video, please like, share and subscribe to my channel. And I hope that this was helpful. I know the video wasn't very well organized or very well planned, but it was a kind of a help to a viewer of mine, and I'm really grateful that she requested me to give this small explanation about all of these topics. And thank you so much for watching.